In a remote corner of the Milky Way galaxy, something very interesting is happening. Us. Our solar system has spun its course for billions of years, and will continue for billions more. One might be tempted to think it will continue on forever, but that is not the case. In fact, the days of the inner solar system are numbered, and that includes us. Our story begins with Mars, the fourth planet from the Sun. Mars is roughly 227 million kilometers from the Sun. It's about half the size of the Earth, with an average temperature of minus 63 degrees. As we travel inward toward the Sun, we come to our home, the Earth. Earth is 150 million kilometers from the Sun, with an average temperature of 14 degrees. It is home to nearly 9 million different species of plants and animals, and is the only planet in our solar system known to harbor life. So far. Further inward, we find Venus. At 108 million kilometers from the Sun, Venus is a seemingly tranquil planet. But beneath its calm exterior lies a deadly world, with poisonous air, crushing atmospheric pressure, and a surface temperature of over 460 degrees. The last stop on our journey toward the Sun is Mercury. More like our moon than a planet, Mercury has no atmosphere and is covered with impact craters from billions of years of cosmic bombardment. At 58 million kilometers out, it is the closest planet to our home star, the Sun. Because our Sun is so incredibly massive, the inward force caused by its gravity is unbelievably strong. This inward push is so great that the hydrogen atoms of which it's made are fused together to form helium, and in the process give off tremendous amounts of energy. It's like an ongoing, slow-motion hydrogen bomb, pushing outward with the same amount of force that gravity exerts inward. This cosmic balancing act keeps our Sun burning steadily for billions of years. But nothing lasts forever. The Sun will eventually use up all of its hydrogen fuel, and the fusion of hydrogen into helium will come to an end, as will the force that keeps gravity in check. Without it, the Sun will begin to collapse in on itself. But this collapse will cause the temperature and pressure of the Sun's core to rise. In fact, it will rise high enough that the helium of which the Sun is now composed will fuse into carbon, in essence giving the Sun a second life. But at what cost? The fusion of helium into carbon produces much more energy than did the Sun's previous fusion process. This second, more powerful round of fusion will cause our Sun to become enormous. For the next billion years or so, our Sun will be a red giant. It will expand past the orbits of Mercury, Venus, and Earth. These three planets will be no more. In its red giant phase, as the Sun expands, it will get thinner and thinner until only a wisp of its former self remains. This thin cloud of gas is called a planetary nebula. At the center of this dramatic conclusion is the Sun's corpse, an incredibly hot ball of pure carbon, a white dwarf star. While its mass is nearly that of its old self, it is much more compact, about the size of the Earth. Because it is not large enough to fuse carbon into heavier elements, it will simply cool over billions of years until finally it is as cold as space itself. It will spend the rest of eternity as a black dwarf star.